Okay, welcome back. This is a continuation of our ongoing series, which we're calling Minding Emotions. And this is an episode that is our third episode. But of course, each of these conversations are standalone conversations, and I think you can watch them or listen to them on their own. But if you want to go back and get the other two, that's fun too. We're going to start out with our usual little clip. It's a bit of a film clip, our classic puppet show scenario. And this one has our friend and colleague from the research group in Mind Science Culture, Glenn Curran, talking about the unique aspects of human emotion. So he's going to be talking about the neocortex. And then this is a couple of minutes long, and when he's done, Rami and I will have a full discussion of it. So without further ado, here comes our video.
The research group in Mind Science and Culture presents The Evolution of Emotion. Part 3. Why are human emotions unique?
Affect is a precursor to more complex human emotions. Human beings have greatly expanded neocortices, which modify deeper effective adaptations into the complex emotional states that we experience. The human brain's ability to modulate and elaborate these effective adaptations is more complex and dynamic than the abilities of our chimpanzee cousins, and even more so than our distant monkey relatives, precisely because of the neocortex. Let me give you an example. The capacity to delay gratification has been recognized as a fundamental characteristic of human psychological development. In terms of emotions, delayed gratification refers to the ability of a person to suppress an impulsive or instinctual behavior based upon the knowledge that doing so will lead to some even more satisfying reward in the future. As expected, it has been shown that this ability is more developed in humans than in our chimp and monkey relatives. And the ability to control impulsive and instinctual behavior is linked to activity in the parts of our more highly developed neocortex. In the late 1960s and early 1970s, a series of experiments known as the Stanford Marshmallow Experiments tested the capacity of delayed gratification in young children. In the experiment, children were offered a reward, a single marshmallow, but were told that if they waited 15 minutes, they could have 3 marshmallows instead, an obviously greater reward. The results demonstrated that some school children were able to delay gratification more effectively than others. The average delay time was about 8.5 minutes. Importantly, a follow-up test showed that the neocortex was more active in the children who could delay longer than it was in those who delayed less. These results show how the neocortex is a dynamic and powerful modifier of effective adaptations in the mammalian brain. The desire to eat food is an old mammalian drive originating deep within the effective parts of the brain. But the neocortex has the power to understand the rules of the experiment, to map out a future where waiting will lead to an even more satisfying reward, and to suppress the desire to eat the first marshmallow and adjust behavior accordingly. Chimps and monkeys are not as good at delayed gratification. Similar experiments show that monkeys are less able to delay gratification than chimps, and chimps less than humans. These results are consistent with the evolutionary trajectory of the human brain, showing that the expanded neocortex has a greater capacity to modify and elaborate the effective adaptations sketched out in the shared foundations of the mammal brain. It is the ability of the human neocortex to powerfully elaborate and modify effective foundations that has given rise to complex human emotion, behavior, and culture. Our greatly expanded neocortex differentiates us from our mammalian relatives. That being said, it is important to remember that the effective foundations we share with all mammals, and their less complex neocortices, mean that the difference between us and them is not a categorical difference, but merely a matter of degree. As we continue to explore the mammal brain, we continue to open the Pandora's box of human nature, and at the same time, we continue to trace the roots of that nature to the biological evolution of the mammal brain. Human evolution largely includes the adaptation of our effective mammalian brains into new domains.
Okay, welcome back, and my name is Stephen Asma, and I'm a professor of philosophy at Columbia College Chicago and a member of the research group in Mind Science and Culture, And with me today, as always, is
Rami Gabriel. I'm a associate professor of psychology at Columbia College and also a member of the research group in mind, science, and culture.
great. And today we're talking about human emotion in particular, but as it continues, as it emerges out of the mammal systems that we've been talking about in the past, one thing that comes up of interest in this discussion that we just saw is this delayed gratification test, this Stanford marshmallow test. And I know it's kind of standard fare for psych classes to talk about this. And I love you see like videos on YouTube of kids basically like they'll take the marshmallow and they'll lick it and they'll put it back. And but I wanted to ask you, let's start out with this, Rami. How important is this ability to delay gratification for human beings, like for our psychology and for our social and cultural life?
Yeah, it's a good question, and clearly psychologists have found it essential because if you look at the further narrative or the further way we talk about it, we talk about how this process we call this kind of ability to stop oneself inhibition. And it's part of one of the executive processes. And all the executive processes are said to be housed in the frontal cortex or the prefrontal cortices. There's another narrative in psychology that, this is the unique part of the human brain, the prefrontal, some parts of the prefrontal cortices, because no other apes have it in the same sort of structural equivalent. So there's a lot of emphasis put on that as one of the uniquely human attributes of the human mind. And there's a lot of books that were published maybe 10 years ago called What Makes Us Human. Xanaga had one, for example, and several others had one. That was kind of a publishing movement. You have these things. So they talked a lot about this in particular, that we have inhibition. That we have executive processes, which is another word for the old school philosophy term will, free will, or the philosophy of mind term agency. So these are all in a constellation, and I think we'll have a lot to talk about with that. But it's said to be the determining factor of why we're human, that we can stop ourselves from doing things. And I think if we unfolded that a little, we'd talk about, who is ourselves? What are we stopping? And I think what we're stopping is the things we talked about last time, which is our sort of shared mammalian emotional drives, instincts, desires. Desire becomes very complicated with human beings too. But this has come to be such an essential part of our narrative in psychology, and I'd be happy to take it apart a little bit. Because it is, even Plato talked a little bit about this, right? You have these two beasts in here, and then you have the charioteer, which is reason. But in this case, when reason is stopping them, halting them, that's inhibition. Whereas when he's directing them, then that's a little bit like rationality. But in the computer sort of cognitive science way of talking about psychology, we say that your inhibitive processes are in your prefrontal cortices, and famous cases they can be weakened. So, for example, Phineas Gage is one of the examples we always give. Phineas Gage got that thing through here and went out his forehead here, and he became a gambler, and he joined the circus, which, as you know, if you join the circus, you're trouble. Yeah, you crossed the line. So, and they say, well, yeah, he joined the circus. He gambled. He must have lost his inhibitions. And then we see, of course, as you and I both know from being around nightclubs and music, that when you drink too much, you're incapacitating your inhibitions, and the drunk people that we see in those situations are very much saying the very silly things that they wouldn't say otherwise. The idea is that they're self-obliterating inhibition. So that's a start.
Yeah. Do you think that if you put like a a drunk person in an fMRI machine, which seems to me
Someone did it.
Somebody's got to be doing this, right? Would you find that that sort of prefrontal cortex activity would be lowered by alcohol consumption? I mean, that would be predicted by this view, right? That I'm just wondering if there's any confirmation from that quadrant.
Well, there's a few things going on when you're drunk. There's differences in your GABA levels. And so you have these neuroanatomical differences, I guess. So I don't know. I'm sure someone's done this, so someone can correct this. But I don't know how much you'd see lower activation than you would see impoverished interconnectivity due to a paucity of neurotransmitters.
Okay.
And then, so you have one neurotransmitter that takes things up, like the main excitatory and then the main inhibitory. When you drink, you're turning down the excitatory and up the inhibitory. So I would say it's a connectivity issue across the brain. And then, of course, there's changes in semicircular canals and your balance, orientation, things like that.
The cerebellum stuff, right?
No, semicircular canals, like where your hearing is and where your balance is, that gets infiltrated by alcohol and changes the concentrations of the fluids.
Well, it sounds like, there is this, what I would call a kind of folk language and these folk traditions, even philosophical traditions of talking about how you disinhibit your executive function. You want to basically take the brake off because I think many people argue that creativity can really flourish once you remove the kind of vigilant executive control. So artists have always been drawn to intoxication. Religious ecstasy traditions are drawn towards removing, this kind of vigilant self. And even simple things like, taking nature hikes and so forth seems to relax some of the frontality or whatever. But I think there's this tradition too that where Freud would have used this very different language, that you somehow need this ability, and it is inhibition, but it's a kind of learned developmental repression. You have to acquire repression mechanics in order to, from basic potty training, as an individual, but to also for a society to function as a whole, we have to constantly check those emotional tendencies towards anger or rage or whatever in order to just be a cooperative species. So do you think that the more recent, fMRI data and this sort of the brain science version is just delivering on the same insights that Freud saw via a different direction?
Well, localization is another part of the story. It might not. I don't find localization to be particularly convincing in terms of further explaining function, because, like you said, Freud did talk about that, and then Plato did, and we have all kinds of discussions of agency way before we were able to look at the brain. It strikes me that let me try to get this again.
The reason why I'm asking is that there's a strong contrast between the kind of inability of chimpanzees to cooperate, and they can't seem to check a lot of their aggression. I mean, they can in the face of like an alpha, but compared to human beings, they're not good cooperators. I'm just wondering.
How much that's culture? Like that's what I was trying to get at. Is that learned? You're talking about learned situations, learned inhibitions, and that's what we call culture now. Like the potty training, it's another parent has to sit there and just push them into it within this context of the bathroom and this version we have of excrement management or whatever. There's this whole cultural system. Mm-hmm. So they're really being enculturated. And then when we talk about chimpanzees, they're being enculturated too. As we know, they do have different cultures, but obviously there's limits to what the parents can pass on. And I guess I would say that the extent of culture is far more shallow. And I mean I guess that would be a good question. How much of our culture requires inhibition to be passed on and to be maintained?
Yeah, you raise a very good point. Look at that difference between chimpanzees and bonobos that we've talked about before. Presumably, we share the same lust system that Jaak Panksepp identified, in mammals. We're all great apes, human beings, bonobos, chimps. When chimps feel, well, let's see, how do we articulate this? When human beings feel lust, they can't just act on it, like in the middle of the street or whatever, in the middle of your job. And yet, so we have a cultural restraint on the lust system. But if you're a bonobo, that cultural restraint on lust is either very relaxed or it channels those kinds of activities in very different ways. Like bonobos, for example, will engage in sex even if they are having some anxiety or tension about food sharing, or males and males, females and females. They'll sort of be having sex all the time as a way to manage their emotional lives. So it's almost like the culture has taken the same affective energy, in this case lust, and sort of redirected it or restructured it so that chimps and bonobos and humans have very different kind of sex lives.
Yeah, that's extremely dramatic version that Frans de Waal has documented. That's what the bonobos do. Every time there's a food sharing issue, they start to have sex to deal with the tensions. And I'm curious, there must be literature about when humans are in sort of these, where they're sort of cut off, these sort of situations, these isolating situations, how their lust systems function. But there's that famous story of after they liberated the concentration camps, that the one thing the women wanted was lipstick, to feel like humans again, to feel like they were in that game again. And then there was a lot of sexual encounters after. I mean, there's a lot of things going on in that example, but I'm curious how the lust was interpreted, changed by that cultural atmosphere.
That's very interesting.
Or jail, prison.
Yeah.
There's all kinds of horrifying stories about prison and rape and how lust gets transformed in that situation.
Yeah, this raises the question, I think, the main topic really, which is this idea of that there are these layers of emotional sophistication, or in a way, we've got this low level or primary process. This is basically the idea that, again, Jaak Panksepp developed, but others have agreed, including Paul Ekman and Damasio and many others, that there are these basic emotions, and Panksepp calls them primary process emotions. So these would be like he thought they sort of all ran through the para-aqueductal gray, the PAG. They're sort of somehow integrated there, and then they emerge up into the limbic system, where there's some kind of a secondary processing, and here, this is the way in which, correct me if I'm wrong here, but emotions you can learn with emotional experiences. So this is the layer of conditioning. It's not like an automatic reflex, but it's more like fear can be conditioned to certain stimuli and this kind of thing. And then the last level is something that Panksepp at least calls tertiary processing, which is that now these same emotions have emerged into what we were describing before as like the cortical
cortex.
Cortex and the frontal areas. And so now you've got thought, and you've got representation, representational abilities, you've got logic, language,
Language.
concepts, maybe a concept of self, something like this, memory, manipulation.
Yeah, I think this is worth talking about more because there has been, and I think it's been dramatized last year with this book by Barrett,
Lisa
where
Feldman Barrett, yeah.
where she's talking about emotions as social constructs, and she brings up the examples of these complicated emotions that we have as humans, saying, look, this stuff is so complicated, it must be a social construct. And of course, there's a larger argument. And then, sort of the conferences I was going to a few years ago, I was going to this SANS, Social and Affective Neuroscience Society, and it's still hot. And in those ones, there's also this emphasis upon these higher level, sort of, I would say, cortical emotions. But then, if you look at the literature in neuroscience or on rats and mice, we have tons of data of that. Those ones tend to be focusing not on the cortical sort of emotions, but on these more basic ones. And I think Panksepp is the great researcher on this. And he's saying, look at all these emotions, these 7 or these more basic ones, these basic, more basic survival ones, I guess you could say. And then, so it's kind of like this limbic and hindbrain kind of stuff. So and there's arguments across these camps, and they don't necessarily coalesce on an interpretation of these things. And I think one of the reasons is they're looking at different levels of emotional function, different levels of emotional evolution, and I don't think there's enough of a understanding that this might be due to stages in evolution. And of course, the most complicated question is how do our cortical enculturated linguistic brains interpret and change all those other ones into what we do? There's kind of this idea that there's this reified notion of there's a reified notion of emotions at this tertiary level, and I think that that's causing some misunderstandings and some misdirection in the way we study things. And I also have some reasons to think that in terms of the history of psychology, in terms of the dominance of the cognitive paradigm, and how neuroscience imaging arose from a cognitive paradigm. And there's a certain methodology of research you do for that stuff, and that's just being put onto a different topics. Like now it's on the topic of emotions and sociality, but it's the same methods, you see? And so when you use that epistemology, you're going to get the same kinds of knowledge claims, but on a different topic.
Yeah, that's very interesting and helpful. And related to this, I was just reading, there's a new paper by Joseph Ledoux, and there's another co-author who I can't remember, but this is a 2017 paper, and you and I think many listeners are familiar with Joseph Ledoux as the guy that really helped us understand the importance of the amygdala in terms of like strong emotions like fear. But what's interesting about this paper is I would have grouped him originally with, the Darwinians, the Damasios, the Pankseps, but in fact he thinks that these subcortical processes are all unconscious, and it doesn't become an emotion like real fear until it crosses some what do I want to say? Like it raises up into what he thinks of as the conscious cognitive system. And once it gets into that domain, it becomes what we recognize as fear. And he thinks that this conscious level is very sophisticated, as far as I can tell. He thinks it's all this stuff we were talking about that's in the cortex, like we were saying, language, concepts, representation. He even says you have to have a sense of self for it to be a real emotion. And I'm fairly skeptical of this view. I can see why, like you were saying, that with the new attractiveness of Lisa Feldman Barrett's work and the way in which there's a kind of epistemology tilted towards human emotions, I can see why this is attractive to people, because they want to claim that you have a kind of inner subjective relationship with your emotions. They'll acknowledge that, but they almost, and in fact, Ledoux surprised me by saying in this recent article that he sort of wants to reintroduce the distancing with animals again, and ascribe what looks like emotion in animals to something more like unconscious survival behaviors. And in this sense, there's a big tension between somebody like Ledoux and this sort of readout theory that probably goes back to James and Lang, and then people like Panksepp and even, of course, like Franz de Waal, right, who think it's not anthropomorphism. They're really having emotions. So one question is, where's the consciousness? Is the consciousness at these root levels of really the primary base, like you were saying, hindbrain emotions, or do you have to wait till it gets up into the human cortex before it qualifies as a conscious emotion? And so, what's your take on this?
Well, yeah, this is a really great thing. This is where we're at, I think, as a science. And so, two reflections. One is that I think that the where Ledoux is coming from is very much in the Stoic tradition, and there is something to the Stoics. As you know, when you read them again, you think, there's something to this. The idea that something comes up and then you either assent to it or dissent from it. There is that element in emotional life. There is that little veto time, or that little window. And then furthermore, since we are already linguistic and conceptual, everything seems to be coming through that filter anyways.
Right.
So there's an element of our subjective emotional life that is captured by that portrayal. Now, on the other hand, I find it revolutionary. And I remember seeing Jaak Panksepp talk, 15, 17 years ago or something. I remember him saying that as soon as you have these sort of emotional systems, you are also sentient. There's also consciousness at that exact same level. It's not like you have to wait for consciousness up here. And I've studied consciousness a lot, and I found that the longer you delay consciousness in the evolutionary tree, the more lost you are. Although there's interesting things with Julian Jaynes. I think we might have talked about this before. That stuff is interesting, but I don't think it's right. But I do think it's interesting. I do think that revolutionary view that he's putting forward, that as soon as you have emotions have to be felt. There's a felt aspect of emotions. So I think that's a revolutionary view, and I can understand why other researchers want to wait till concepts, culture, emotion, or this magical thing called the cortex. But there is cortex in other animals. There's cortex almost all the way down. It's just really small, and it's in percentage of the surface area of other animal brains. It's not a lot, but there's cortex. So I don't think there's a magic bullet of the cortex, and then there's consciousness. I do think that language is a sort of magic bullet, because then there's an elaboration of it and a conceptualizing of there's a reification, I guess I would say, that happens at that level.
Yeah, that makes sense, and I also think like there's one advantage of the idea that there's subcortical consciousness is that it jives so well with the kinds of insights we're now getting in terms of like System 1, System 2, hot cognition. Yeah, the Daniel Kahneman stuff, the idea of a hot cognition, cold cognition system, a dorsal and a ventral pathway in the brain. This makes sense to me. I have to say conceptually, in other words, I think there's some growing data and research programs that are in many ways in support of the idea that consciousness goes way down into the animal's sentience. But I also think conceptually there's something interesting here too, which is the way Ledoux describes it is he says, you've got like a stimulus that comes into the perceptual system, and then that goes basically to the amygdala, and the amygdala is set up to create survival behaviors. And so I get it, that can happen all unconsciously, okay? But the beauty of thinking of the emotions as conscious all the way down is that the alternative is that perception goes into, the stimulus goes into the perception goes into the amygdala, and the amygdala really is where fear happens, or at least fear is processed. It's the subjective feeling, that negative emotion, that actually then drives the behaviors. And without that, it seems to me on that first model I gave, you've got to wait for it all to be processed. You've got to wait for it all to be somehow represented in the system, and also have to have a sense of the self, and all of this takes way more time. It's not a very efficient system for getting out of the way of something that's chasing you, whereas the fear system it seems to me, would be much faster.
Yeah, and I guess you're also dramatizing this idea of the expression of the emotion.
Right.
There are some people who say, well, you can express these behaviorist types or these neuroscience, like in Ledoux's case, where, yeah, you can express it, but it doesn't mean you have it.
Yeah.
And then on the other side, there's this anthropomorphic, well, not totally anthropomorphic, but just kind of an empathetic, in a way, a cross-species empathy, maybe. I mean, it's hard to say what's... There's also theoretical motivations, of course, but people saying, well, if you're expressing it, then you're also having that emotion. And that's something that's been really complicated in psychology. Some people want to say, well, expression is just your body twitching. It's just some reflex thing. It doesn't mean you're having it. And other people are saying, well, if that's what we're doing too, and we're obviously having the emotion,
right,
then it can get really complicated with these eliminativists, the Churchlands, who are like, well, yeah, of course, there are these other behaviorists saying, yeah, you're not really having it anyways. You're not really having the emotion at all. It's all reflexes and language games. So it got really neurotic in the 20th century.
Well, it's funny. Yeah, it's funny that you can see where the epistemology of behaviorism would, of course, prefer just the behaviors, and then you have to take an agnostic view about what the animal's feeling. But then along comes all this new neuroscience data that shows, oh, actually, there's subcortical processing happening, and the kind of stuff that Jacques was doing experimentally with electrical stimulation of the brain. And still, we have to remain, or many people want to remain, because of the epistemology, they want to remain agnostic about it. Mm. But I think what I like about Franz de Waal is he's just like, come on, enough is enough. If it screams like it's in pain and it's writhing like it's in pain, it's in pain. And if I can make that judgment about you, which also I have a Cartesian problem with because there's always a problem of other minds, then I can make that assessment about an animal, that is engaging in what looks like emotional behavior. So this is why I sort of lean in that direction, and I think it's why somebody like Panksepp was so loved by the animal welfare crowd, because Panksepp, argued that the animal really does have a rich emotional life. It's not just sham fear or fake emotion. It really is experiencing pain, and I think that's why he was so beloved by that community. All right. Mm-hmm. Anything else on this topic, or should we move on?
No, I mean, I don't want to open the box, but maybe we should do a whole thing about about fish.
Yeah, we should.
That's just because they're writhing but we don't know if it's because of the oxygen. I mean, fish is something we should tackle at some point.
Yeah, we should. Well, this is interesting. Let's try to devote a whole discussion to that.
Fish.
But
okay.
To fish. It'll be the fish show. but one thing that does seem like relevant here is that in the case of mammals, they do seem to be motivated largely by, I would say, subjective experiences of pain and pleasure, and that. But I do think there are behavioral responses to threats that we could more easily claim to be automatic, robotic, purely, nobody's home. And this is the debate really about fish insects. I was just listening to this radio show, and this guy, he raises like these big insects, beetles, and he said he was closing the lid on one of these beetles, and he dropped it, and it hit the beetle accidentally, and the beetle fell back into the cage, and he had accidentally ruptured the belly of this thing, so its guts had sort of like popped out, and he looks down on it, and he's like, oh, shoot, I've hurt my beetle, and all of a sudden he realizes the beetle is now starting to eat its own guts, and he's just like stunned by this, like this is so bizarre. No mammal would just start eating themselves under such a condition. And his argument was, well, it must have a very simple, mechanical system where when you smell fat, eat, because in 9 times out of 10, that's going to be somebody else's fat. And by eating that, you're going to survive better. 1 out of 10 times, it's your own fat, and you're eating yourself. But the animal doesn't know any of this. The animal can't feel any of this.
You have a perverse imagination, man. I don't know what to say.
So what I'm saying is that in those cases, the insect has would be having behaviors that might be looking like they're in pain, but we can more reasonably have skepticism or agnosticism about insect pain. I don't know.
Well, the other side of, I think the strongest argument for me about insects not having emotions is that they don't have the cortical material. And I don't know if that's some sort of...
What about the subcortical material?
I don't think so. I think they're pretty much like a centralized bundle of nerves. I don't think it's a brain.
Actually, there is something, we should take a look at it. Maybe some viewers could put it in the comments section, but I think our mutual friend, Colin Klein, who's now in Australia, just came out with a paper maybe last year, and they are looking at insect brains. And I think this is something, I don't know what the results were, I'll have to read that paper, but maybe we're going to find that if they have well, let me ask you this, if you found that they have some rudimentary sort of subcortical anatomical parts that corresponded, would that be enough for you to go, I'll err on the side of caution?
I mean, it's very interesting because we did look into this once, and we found that insects do have analogous neurotransmitters. Remember we looked at that?
Yeah,
once?
That's right.
And that was very surprising to me, and I guess that's something to look into, because if they have analogous neurotransmitters and analogous structures, centralized nerve structures, then it's a different question for me. But it's not homologous.
Right.
Right?
I mean, only in the most remote sort of way. It's not like you and I and a squirrel, where the phylogenetic connection is close, much closer. We're mammals.
Yeah.
And it seems to me that most of the stuff you find in insects and mammals is convergent evolution. They're analogs, not homologs,
Right.
So that makes me skeptical too.
Yeah, and that's the question, I think, and even a better, something that I would be more likely to assent to would be birds.
Yeah, right.
There are analogs too.
Yeah.
But the behaviors and the cultural structure of raising your young makes me have more sympathy to it. And I don't know how much of this is also sort of, species prejudice, but also evidence-wise, it does seem to me like structural factors have to be one of the highest considerations to make a judgment on this.
Yeah, I agree. I'm reminded, though, because you were talking about some of it could be species-centric. I think there's a line in Daniel Dennett's book, Kinds of Minds. I think it's in Kinds of Minds, where he says, "You're not inclined to think that the spider or the fly, is feeling pain when you pull its arm off or whatever. But if you just make the size much bigger of a fly or an insect, then we're much more likely to to recognize or project that the animal's in pain, or any of the other properties that we might ascribe to mammals.
Yeah. It reminds me of Leibniz too. Leibniz says, "What if the brain was huge and you could walk in the room,
right.
see them all?" Which is also makes you think, "Whoa," about mechanization, about those kind of things.
Yeah, that's right.
These guys had these Gulliver, these Lilliputian.
These great metaphors and
Yeah.
analogies. So there's a connected story here that I'm really interested in. I want to see if I can connect it to what we were just talking about. There is this sort of conversation that's happening in the sort of blogosphere and in the podcasts about AI that's really interesting now, which is it's called, it's not the containment problem. It's like more of what they're calling an alignment problem, where the idea is if you made an artificial intelligence that achieved a certain level of intelligence, would its goals, its teleological orientation be aligned with the human beings that created it? And the worry is that they would misalign fairly quickly. And as far as I can tell, there seem to be two concerns. One is the old sci-fi version, which is a very elaborate artificial intelligence could, through some kind of emergence, end up having its own teleological agenda of survival. And it might be that human survival is just in the way of that teleological.
Terminator 2,
right.
for example.
So that's the version that I think is more well known. But the version that's now coming to be more realistically entertained is sort of a softer version, which is that the AI doesn't develop its own survival instincts, but the programming we give it, however arbitrary and seemingly simple, like the analogy you see sort of making the rounds is you assign AI the task of creating paper clips and sort of putting paper clips wherever they can. It might be that even a dumb program like that might misalign with human interests, such that AI would just be trying to solve that problem over and over again, such that we're actually eliminated from the picture. And it got me thinking, I'm not that interested in this problem, but it did get me thinking about what we were talking about, which is this teleology question. Mm-hmm. Like, can the stuff we're talking about, that there's an emotional mammal lineage where mammals have intentionality or teleology to survive. We were talking before about Spinoza's conatus and so forth. Could AI ever achieve its own teleology? Because I think the assumption is once you get general intelligence, that's the dangerous thing. But I'm not sure you could ever have general intelligence without affective preferences, without having, you know what I'm saying? Like,
well, I guess I think the onus lies with what kind of developmental rules you put into these robots, like your beloved Roomba.
Right. Don't disparage my Roomba.
But your Roomba has learned your room.
Right.
And it does it by bumping into things, and then it eventually sorts itself out. There's a lot of robot stuff where they've realized that don't put all the information into it, but give it a exploratory computational function, and then let it map according to what it learns. And I think that eventually these robots, the successful ones, are going to have that. They're just going to have, well, just like with humans, you give them the genetic material, and then they have to grow up. And then the developmental period is really what calibrates all those things and then sets it going forward. Same thing with humans, we can get calibrated really incorrectly developmentally, and then you have all kinds of heinous acts that humans are committing. And part of that is that developmental period, I believe. So I don't think so much the initial rules of the AI programming is as important as the developmental algorithms and then how those things get filled in.
But I agree with you, but I'm wondering, in human beings, and I think in mammals, what's happening during this developmental phase that you're describing is that the affective preferences are being, in a sense, mapped. And so feelings of pain, pleasure, attraction, repulsion are being basically coded into, the environment's being coded with this stuff. So then we, here following like Antonio Damasio, we tilt, when we have a series of options, we tilt in a certain direction because there's an affective valence or something that leans us. And I just think there's almost like two different systems happening where I don't think you're going to be able to make AI that's like the mammal phylogeny system of preferential decision making. But I do think you might be able to make AI modeled more like the insect level of decision making, which is just this computational stuff. And in that case, I would think the developmental learning would not be affectively coding, but would be informational coding.
Yeah, I think that like the stuff we've talked about in the past is connectionism models, the
Right.
PDP models, and those are preference nodes, but there is no affect behind it. I think for both of us, affect has some sort of subjective dimension.
Right.
That valence is not just a preference in an electrical pathway. But that's happening too, and that's happening with our reflexes, and that's why we learn how to do all these kind of things. But obviously, in most cases, some of the complicated things we do on our instruments or on our walking or athletes, there are these nodes, the developmental nodes, but they're not always paired with valence. And I think that's more what it would look like to make these AI monsters.
I wonder if you would need, this distinction we have between an AI that develops a self-interest versus an AI that just relentlessly, follows out its imperative. I wonder if the difference there is affective or emotional, subjectivity. You see what I'm saying?
Well, what would you call an interest? Like, what's an example of an interest that a...
Well, like, I'm thinking about, okay, if you think about HAL 9000, right, in 2001 Space Odyssey.
Yeah.
The question is HAL, does HAL emerge his own interests such that he wants to kill the crew and basically, kill Dave? Or is it the case that HAL is simply following out his interests, and here I mean the directives that he was given in programming? And I don't think the film is clear on this, but I think the novel is clear that it's the second one. That what I think, if I'm remembering the novel right, Hal has been given two directives. One is communicate truthfully and clearly to the humans, and the second one is do not tell the human crew that we've made contact with, alien life, because they won't be able to handle it. This is how it's cashed out in the book. So somehow Hal, has these two conflicting codings, and then his solution is if I kill the crew, I won't have to violate one of my directives. See what I'm saying?
Yeah.
So it's like he doesn't emerge into somebody who wants to survive and eliminate the humans so that he can survive. He eliminates the humans so that his directives will align better.
Mm-hmm.
You see what I'm saying?
Yeah.
And I guess what I'm asking is, where do you think the emotions, or even this really rudimentary form of emotion like conatus, is that the game changer? Is that the thing that the intelligent form needs to have in order for it to be defending its own existence?
Well, it strikes me that when we're talking about this, how much of our discussions of AI center on the battle between us and these machines.
Right.
And it strikes me that there's always something like, will the machines kill us? And it does seem like that's sort of an endpoint of most of our human discussions about the future. Are we going to have a bomb?
Right.
And then when we get into emotions, like you're saying, I do think that that's one of the reasons. Emotions are kind of a human and animal bonding mechanisms. And so we always want to talk about those because those are the things that have kept us. That's part of the glue of humanity, the love of humanity, these old romantic sayings, these German sayings. That stuff that's an emotional discussion. That's a discussion about emotions. And then such that when we get to this question about machines, we want to go right back to the emotions thing and say they don't have the emotions, so they're not part of this game. They're not part of this cultural sphere.
The solidarity that we have with animals, they're not part of it.
They're not part of it, and that's why there's an impending destruction point. And there's a similar thing about the nuclear bomb idea, that nuclear bomb doesn't care, and that you can eliminate all these people at once. It's this totally inhumane level. So I feel like this discussion is tied to our discussion of what is world order, or the ancient Egyptians called it Mat. What's justice or world order? What falls inside it, what doesn't? And when we start getting to these things that are going to transcend us, like machines, then we start to get close to that point of things that are not part of the world order.
That makes sense to me too, and it reminds me, because I had written this book on monsters, and it does seem like we're in the era where our technological fears basically go right along this fault line that you're talking about. And also, in addition to artificial intelligence having no way to negotiate because there's no shared emotional life, this is why I think insects are so particularly horrifying, especially when you make them really big, which is what, like if you look at the series of films like Alien 1, 2, 3, 4, I don't know what we're up to now, it's basically a giant bug. And this bug is much better at surviving than you and I are. It's winning the Darwinian game. It doesn't share the emotional solidarity that we have with the mammals. And there's something uniquely horrifying about that because, like you said, it's not within our world, meaning this smaller domain of shared, emotional. You can't appeal to them on the grounds of reason. They don't have it. You can't hug it out with emotions because they don't have those either. So there's a sense in which there's a real parallel, I think, between the insect realm and the robotic fears, and it's this missing ingredient of emotions.
Yeah, it happens too when Odysseus is in the Cyclops with the Cyclops, and the Cyclops they all live alone.
Yeah,
they're not part of some community, and so he doesn't know how. And then he can't tell him, we want to go back home. The guy doesn't care.
Yeah, that's right.
So he's now in he's outside the order, and all that Greek, all that Odysseus stuff is like, wow, look at the rest of this world. It's a bunch of barbarians and weird crap, and it's not part of the world order, the Greek world order. They're barbars.
Yeah, they're barbarians. Yeah.
And I feel that, and then the same thing with the ancient Egyptians. They didn't want to leave Egypt. Everything outside of it was called chaos.
That's right. Interesting.
Yeah.
Oh, that's great. Well, it ties to one other point that I'd like us to talk about, and then we'll probably wrap up. But I was looking at some studies recently about emotional expression, and there are two studies that I was reading recently about the way in which we culturally decode emotional facial expressions. And one of the things, this last conversation here reminds me of, like, where are the circles of solidarity? One of the studies was done by a Japanese researcher named Masuda, and this is from 2008. And Masuda did sort of eye tracking, gaze, and found that when shown a group of people, images, Westerners would look at the individual subject that the researchers were asking, what's the emotion that person, let's say Bob, is having. And they would read the face, and they would just report. It's, downturned mouth, eyes, like this, the guy's sad. But their findings suggested that when Asians looked at the group, their eyes would go to the central figure, but then they would read the emotions on the other figures' faces, and then they would incorporate that, and oftentimes that would override how they reported Bob to be feeling. So if you saw like Bob looks sad, but everybody around him is laughing, the Asian subjects were more likely to report that Bob was happy or was. And so her interpretation of this is, that Westerners tend to think of emotions as individually, fixed or located, whereas Asians tend to see emotions more in terms of groups or maybe socially distributed or something. Do you have any thoughts on it?
Yeah, I do. I have this chapter on this in my consumerism book, where I talk about marketing in different cultures.
Explain that.
The global marketing literature discusses how if you're going to do advertising in a collectivist society, like I'm not sure which Asian country you're talking about, but it's most probably a collectivist society,
right,
that you do things differently. You try to make the brand part of the family, basically, and you consider it in terms of how do you, in terms of what are other people going to think of you within your spheres. The brands are longer term, whereas here, if you market in the West, you're supposed to market to the individual primarily. So there's even these differences in how marketing is done. So that makes sense to me about the experiments that he looked at what others thought, because that's the rubric is the collectivist rubric is you look at the group, you look at the context. The social context is more important than the individual context. Very
interesting.
Yeah.
That jives with my experience too, just living in Asian countries. Yeah. So you're saying like if you're trying to sell like a soft drink or something, you want to make sure that the images are like of families or whole groups enjoying rather than the individual, like in an athletic competition beating out others or something like that.
In general, and that in general bears out the experiments I did in my book. We're looking at the Middle East, so we're looking at Egypt versus France and America. And in general, we found a collectivist slant to the Egyptian advertisements. But in China, there's way more literature about how it's working out in China. I think Demouge is the person who's done most of this work, and has found that the split is very effective, in fact, in creating advertisements.
Oh, that's interesting, because now you have the rise of consumer culture with a huge middle class in China. Yeah, it'd be interesting to study the ads. One last point related to this, but different and very, very interesting, is there's another study done in the 2009, 2010, and this is studying, like, you look at faces that are sort of racially neutral, and you try to say, is the person having, what emotion are they having? And the findings were that Asians will have a hard time, will oftentimes misidentify a surprise and fear. Like they'll see a face that most Westerners would say is surprise and distinguished from fear, and Asians will say that both cases are fear, and the argument is because when you do the eye tracking on these tests, Asians will look primarily at the eyes and not consider or factor in the mouth. Whereas, like, I was thinking about this, like, if you're afraid, because I was doing the face, I won't be able to do it if I'm laughing, but your mouth turns down and your eyes go real wide. But if you're surprised, your eyes go real wide, just the same, but your mouth goes like, you get more of a round shape in the mouth. And the argument was that the interpretation was they were misidentifying because they weren't looking at the mouth or incorporating in that data into the information. The explanation was, this is just speculative, but the explanation was, it's possible that when you live in a culture like a face culture, ironically, face cultures like China, it's emotionally the style is very repressed, or it's very careful. You don't want to show dramatic emotions in public. It's not a virtue to be like losing your your emotional self. So
Mm-hmm.
people are very
Mm-hmm.
constrained, sort of like the Brits, I suppose, stiff upper lip kind of thing. So the interpretation was, well, maybe people are culturally always muzzling their emotions, like their mouth. And what has happened is culturally Asians have developed such that they look at the eyes more carefully in case they leak the real emotion, because the mouth won't tell you anything. What do you think of this?
Well, I guess I want to just tie it back up to what we started with, since we're
Yeah,
closing it out. But
good.
we talked about inhibition in the beginning. We talked
Right.
about the cultural modes of inhibition. There's different um, versions of learning inhibition. We talked about toilet training and all that stuff. And maybe this is another form. I mean, I really can't speak to like these sort of big general things about Asian emotion. I don't want to say anything silly, but there are different um, contexts and social norms. So there might be a social norm. Now I'm just hypothesizing. There might be a social norm that you don't show fear as much,
Mm-hmm.
and or if you fear, you pretend it's surprise.
Ah, yeah,
That could
interesting.
be that could be a social norm over there. And I don't know. This is completely ridiculous theorizing, but that could be it. That could be the inhibition thing. That when you have fear, instead of that, you inhibit it and make it more of a surprise thing as soon as you can control it.
Yeah, so you can get some like executive. This is very interesting because we've talked about this briefly before, but to talk about inhibition. Remember, I think it's the Maasai people of Kenya that have to undergo a kind of
Right, the public
circumcision. Yeah, right.
circumcision.
Yeah,
Yeah,
and they have to control their facial expression so that it shows no pain,
yeah,
which is talk about the triumph of of inhibition and the frontal cortex or whatever. Because if you can keep your face totally passive while you're being circumcised, that's remarkable, and it shows you the level.
yeah. And you think about public figures who have to lie in public
Right,
uh, for a living.
like all of
Uh,
them.
yeah, it feels like they
Feels
have
like
to.
all of them.
They do. A public figure has to maintain a certain front for the organization,
Yeah,
and it requires inhibiting very automatic, lying and disgust kind of
right,
sentiments. And we marvel at this. We still watch people and we say, "Oh, look, he was lying when he said
right.
this.
Yeah,
Look, Clinton was lying
yeah.
when
That's
he was
right.
sleeping. But look at his face; you can't tell."
That's right.
Or that some people, you look at them, look at their face. They, you know.
Yeah, it's true.
So it's this whole game of inhibition.
Okay, that's a good place for us to sort of wrap up. This has been a really fun conversation. So we'll continue, and next time we'll move on to part 4. But thanks, Rami, as usual, and
Thank you, Steve.
we'll look forward to the next one. All right,
Okay,
take care.
see you.